Welcome to Precalculus Concept video 15b. We're going to find the zeros of a polynomial function. Okay, there's 3 boxes, so let's get into it here. Example 1, we are going to find all of the zeros of the polynomial function f of x equals x to the third plus 2x squared minus 5x minus 6. Okay, we're going to do this not by graphing and not by graphing or factoring by grouping, because we can't in this case, but we're going to use a completely new technique to do it. We're going to follow these 3 steps right here. First, we're going to list all possible rational zeros. Then, from that list, we're going to use synthetic division to find one zero. And then, we're going to factor the result, or find another zero, or use the quadratic formula, whichever one we can do. So let's follow this, protocol here. So let's list all possible rational zeros. So I'm going to take the last number, which is 6, and I'm going to give all the factors. So plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. And I'm going to divide that by the factors of 1, which in this case are just plus or minus 1. So this is my list right up top here. That's basically just the numerator since everything's divided by 1. Okay, now I'm going to use synthetic division, and I'm going to find a 0 from my list. So I could start with 1, -1, 2, -2, 3, -3, 6, or -6. So I can use any one of these. I'm going to go ahead for the sake of the purpose and choose to use the number 2. Okay? So use synthetic division. I'm trying to see if 2 is a 0 of this function. So I'm going to get put 1, and then 2, and then -5, and then -6. Skip a line and draw a line. Prong down, add vertically. 1 times 2 gives me 2. Add vertically, I get 4. 4 times 2 gives me 8. -5 plus an 8 gives me a 3. 3 times 2 gives me 6. Ooh, look at that, a 0. Awesome. So if I get a 0 here, that guarantees that 2 is a 0 of the function, and that means that x minus 2 is a factor. So what do I have left with? This is my remainder, this is my constant, this is my x, and this is my x squared term. So the result would give me x squared plus 4x plus 3 equals 0. Now this is a quadratic, and I can factor this quadratic. I can do x, and a 1, and a 3, and make everything positive. Set this equal to 0. So if x plus 1 times x plus 3 is 0, then it must be true that x is going to be -1, or x is going to be -3. So therefore, all of my zeros are going to be 2, x equals 2, x equals -1, and x equals -3. So notice we did not need to use the calculator, we did not need to graph it, and we did not need to use any sort of factoring. This is a process by which we can find all zeros for any polynomial function. Okay, box number 2 is another example of the same type of problem. We're going to find all the zeros for the following function here. So the first thing that I'm going to do is I'm going to get my list going. So I'm going to take the number 3 and give all the factors, plus or minus 1, plus or minus 3. Pretty straightforward. And then take all the factors of 1, so that's just plus or minus 1, and divide them. So therefore my list is going to be plus or minus 1, plus or minus 3, and that's really all that I have. Step number 2, I'm going to choose one of these 4 here and try and find a 0 to the function. So I'm going to go ahead, for the sake of the video here and your time, I'm going to choose -3. So I'm going to test to see if -3 is a 0. So I'm going to put a 1, a 7, an 11, and then a -3. Skip a line and draw a line. Bring my 1 down and add vertically. This is going to give me -3. 7 take away 3 gives me a value of 4. 4 times -3 is worth -12. -12 and 11 make a -1. -1 times -3 is a positive 3. Ooh, look at that, a 0. So because my remainder is worth 0, that guarantees that -3 is a 0 of the function, which means that x plus 3 is a factor of the function. So here's my remainder, my constant, my x, and my x squared term. So therefore, step number 3, I'm looking at x squared plus 4x minus 1 is equal to 0. So now in this case, I cannot use factoring by any means, but it is a quadratic, so I can use the quadratic formula. So this is our next step. So I would do, okay, A is worth 1, B is worth 4, and C is worth -1. This should look familiar to you guys. Check B squared minus 4AC. That's going to be 4 squared minus 4 times 1 times -1. 4 squared is 16. And then -4 times 1 times -1 is a positive 4, so I'm getting a value of 20 out of here. So therefore, x is going to be -4 plus or minus the square root of 20, all divided by 2. This breaks down to -4 plus or minus 2 rad 5 over 2. Factor out a 2 from the top, leaving you with -2 plus or minus the square root of 5, all divided by 2. Your 2's cancel, and you are left with -2 plus or minus the square root of 5. So one of the answers is going to be -2 plus rad 5, and the other answer is -2 minus rad 5. And you would put this into your calculator, and you would get the approximate response, or you could leave it just like that, whichever one the book wants. I'm okay with either one. But it is to note, you guys, that even though this is a 0 of this function, it did not show up in the list because this number is not a rational number. So remember, the rational zeros theorem only gives you the rational zeros. Okay, box number 3, you are on your own. Try to follow the process I gave for you in box 1 and 2 and come up with all of the zeros for that polynomial right there. Okay, hopefully you got the right answer. The solution was 2 and -3 plus or minus the square root of 5. So how did I do the solution? Well, I first made my list, and I got plus or minus 1, plus or minus 2. I checked to see that if 2 was a 0, and it was because I got 0 in the remainder. So therefore I took a look at the remaining factor part, which gave me x squared plus 3x plus 1. So I then go ahead and factored, or solved using the quadratic formula, and I got -3 plus rad 5 over 2, -3 minus rad 5 over 2. So if you look at the graph, here is the rational root, or the rational 0 at 2. Here is -3 plus rad 5 over 2, and here is -3 minus rad 5 over 2. Hopefully that made a lot of sense to you.